So the topic that we're sharing today is unit of circles, radian. So actually learn the basics in your mathematics. Those formulas that you learn and everything is conducted in degree. However, in this particular part, you will only be given radian. So you're required to set your calculator into radian mode when it comes to this particular topic's calculation. So I'm going to go through a couple of basics here first that involve the conversion of degree into radian and also radian to degree. So we have pi representing 180 degree and we have 2 pi representing 360. So this is a default, and this too, if you memorize it, it will be easier for your own calculation. So I will cover the reason later on. So converting a degree into radian. Let's say you were given 240 degree today. You are required to multiply with pi and divide it with 180 to get to 4/3 pi as your final results. In another case, if you were given as radian, so for you to get back it into degree, we are required to multiply 180 and divide it with pi. So for example, we have 31/18 pi here. When it was being multiplied with 180 and divided by pi, you will get your final results as 310. So this won't be assessed in this particular topic. However, the continuation of this, which is the quadrant concept, and that you need this to identify what does the radian represent if you don't have a solid foundation on your radian topics conversion itself. So the core formulas that you learn here is the arc length formulas as well as the area formula. So the one that I'm showing here in the graph itself is a sector of a circle. If it's a full circle, 2 pi r or 360/360 times 2 pi r will be applied. If it's a sector of the circle, then theta over 360 times 2 pi r. Theta is the angle value of the sector. So today, if you were to convert and calculate it in radian format, so we simply take the radian times the radius, then you get the results. The theta here represents the radian value of the sector. Another thing that students always left out is that perimeter means you need to include all the sides. So remember to add the 2 blue lines that show over there. That's your radius. Moving on to sector or circle area formula, we have pi r squared or 360 divided by 360 times pi r squared. This is for when the shape given is a full circle. If it's just a part of the circle, then theta over 360 degree will be applied. So radian formulas for this area will be 1/2 times theta times r squared. So this formula won't be given in your exam. You're required to memorize it, else you couldn't answer the following question that I'm going to cover. So we have 5 questions that are compiled over here, which shows you different type of question and how do you utilize all this information for you to run the calculation. Before that, I'm going to go through some keynotes that I would like to highlight. Is the first one, as mentioned earlier, perimeter doesn't means that you only calculate the arc length. Please remember to include the 2 radius. And the other thing is area and perimeter calculation is the most common question for this particular topic. Solid foundations on areas or perimeters calculation of different shapes is required, not just for the circles only. So a couple of things that is useful here will be your Pythagoras theorem, your half AB sine C for you to identify the value of a irregular triangles, okay, your normal triangles, area calculation, etc. And the last one will be utilization of different formula to calculate your chord. So for this, for chord calculation, it usually involves cosine rules. So all the things that you've learned previously will be assessed again over here. So let's go through our first example here. Show the angles AOB is 2.08 radians, correct to 2 decimal place. So the keyword that was given by the question is that they gave you the radius as 12, AD's value is 8, and the area of the minor sector AOB is 150 cm squared. So with this being said, we know that we need to utilize the minor sector AOB's area. So half times theta times r squared equals to 150. Theta equals to 150 divided by 1 over 2 divided by 12 squared. By doing so, you will get your final results as 25 over 12, which is 2.08333333, which translates into 2.08. Moving on, the question asks you to calculate about the area of the shaded region, A, D, C, B. So I've broken down the shapes into 3 parts that goes by a rectangle, a sector of a circle, as well as a triangle. So since we don't have DC's or AB's value, so I put an unknown over there. So I have the area of the rectangle as 8 times unknown. As for the sector itself, as calculated earlier, it is 150 cm squared. And for us to calculate the area of the triangle, we actually already have all the information. I just utilize half AB sine C concept, key in the theta's value, which is 2.08 we calculated earlier. And remember, please set your calculator into radian mode. And always after this type of question, please change your calculator back into degree or mathematics mode. If you don't clear the mode and you move on and do other question that involves degree or other things or pi, it will affect your results. So from this calculation, you will get 62.86557452, and correcting it to 3 significant figures, you will get 62.9 cm squared. I also calculated my chord. So A joining to B is actually a chord here. So to do that, I utilized my cosine rule, subbed in everything into the formula, and I gotten it as 20.7. And with this information, I can calculate my rectangle as 8 times 20.7, and the result of it is 165.6. So with all this information, we can now identify the shaded region. So what I did was to take the total area, which is 165.6 cm squared, minus it with 150 minus 62.9, so that I can identify the chord area over there. By doing so, you will get your final results as 78.5. So thing about this is that, remember the AB, the chord that we calculated earlier, this value also transferred to DC's part. So we have a 20.7 over there. So the arc length of this is theta times r, so 2.08 times 12, you get 25. So the final answer will be taking 25 plus 20.7 plus 8, which is your AD's value, and another 8 for your BC's value. So you will get 61.7 as your final answer. And that's pretty much it for example 1. Moving on to example 2, they ask you to show that PAQ is 2.35 radian corrected to 3 significant figures. So let's go through what are the information given to us. They say that the radius is 24 and 10, and they form a tangent. Okay, so what this means is that I can now transfer the shape and I interpret it as above. AP value is 10, PB is 24, and AQ is 10, QB is 24. And the tangent that they mentioned represent the 90 degree over there. So since you have AP and PB's value, this we can identify the angle, or in our case is actually the radian. So we have the opposites and adjacent of it. Utilizing your tangent BAP equals to 24 over 10. So angle PAB value equals tangent inverse 24 over 10. You will get 1.17 600 5207, and this is your radian. However, this is only our PAB's value, not the one requested by the question, PAQ. So to get that, you're required to multiply the results by 2, then you get 2.35. So moving on, we have find angle PBQs in radian. So I repeated the same thing. So this time around, we are focusing on PBA. So our 10 will now be its opposite, and our 24 will be its adjacent. Running the calculation, you get it as 0.394791197. So to get to PBQ, you need to multiply it by 2 and you get the results of 0.79. Alternatively, if you're familiar with the topic already, 180 degree is actually a pi. So pi minus 1 over 2 pi. Why is it 1 over 2 pi? It's because it is 90 degree, which is half of pi. And our angle BAP that we identified earlier is 1.17 600 5207. So minusing it off, okay, then we get 0.394791197. So this is the same as the tangent calculation we did earlier. So multiplied by 2, you will get 0.79 as well. Finding the perimeter of this shaded region basically is a 2 arc length of the shapes. So since we already have their respective radian, we can now calculate the total arc length as 2.35 times 10 and 0.79 times 24. After correcting it to 3 significant figures, you get 42.5 as your final results. And for you to calculate the area of the shaded region, this is the part where it gets hard. So I enlarged the shape they are referring to and I broken it down as below. Angle PAQ equals to 2.35 radian. So I'm required to calculate the sector area minus off with the triangle to get to the chord area. So repeat the same for when angle PBQ is 0.79. So half theta r squared minus 1 over 2 times AB sine C. Run the calculation, then you will get 81.92633.236. As for the other one, you will get the results as 22.938.25754. So I only round up the results after I did all the calculation. So during the process, I won't round it up because it will affect the answer. So my final answer, by adding these two up and correcting it to 3 significant figures, you will get 105 centimeters. Moving on to example 3, we are finding angle theta and finding the length of arc AB. So theta value here, as given by the question, the area sector of AOB is 20. So half times theta times r squared equals to 20. Your theta will be taking 20 divided by half divided by 8 squared. So your final answer for that will be 0.625 radian. As for identifying the arc AB here, all you need to do is to take the theta that we identified earlier, multiply it by 8, then we get the results as 5 centimeters. Find the area of the shaded segment. So you can notice that OD and OC, they didn't tell you the radius value. However, remember for circle, all the radius is the same, so it's only 8. So area of the sector DOC is half times 1.4 radian times 8 square. So you get 44.8 centimeters square for that. And you run your half AB sine C calculation, which is the area of triangle DOC. Through that, you will get your results as 31.5343936. Take 44.8 minus the following results, then you will get 13.3 centimeter square as your answer. Moving on, we have example 4 here. So right angle is a key information. So first thing, I'll put a square at the side to indicate that it is a right angle. The half pi over 2 radian represent 90 degree. So they gave you a PB has 8. So you need to find the rest. Okay, calculate the area of the shaded region. So first thing that I did was to identify the value of ACB. How did I did that was to utilize the information. Total angle of a triangle is a pi, so pi minus 1 over 2 pi minus 2 pi over 9. So I gotten the results as 5 over 18 pi. So that's your radian results of ACB. Next thing that I did was to identifying the BC's length. By using tangent BAC equals to BC over AB. Run the calculation, then you get it as 6.71 centimeters. With this being said, I'm utilizing Pythagoras theorem here because the base square times the height square equals to the hypotenuse, which is AC here. So AC will be 10.4 centimeters. I actually label it as XCM and YCM. If you're confusing what are the X and Y represent, you can look at the triangle that I drew at the side. So with all this, I can now calculate the area of the total triangle by taking half times BC times AB. Then I get 26.84 centimeters square. Area of sector ABD utilizing the 2 pi over 9 multiplied with half, multiplied with the radius square, you get 22.34 centimeters square. And for the last part, which is a smaller sector over there, we already have the radian value, which is 5 pi over 18, and we don't know the radius value yet. So what I did there was to take AC, which is 10.4, minus with 8, so that I can identify the value of the radius. So I gotten my final results as 2.51. So I took the total area minus with the two sectors value, then I get 1.99 centimeters square as the shaded region. Moving on, identifying the perimeters of the sector. I leave most of the information that I gotten earlier intact. Alright. So I first identified BE by taking 6.71 minus 10.4 minus 8. Through that, I will get my results as 4.31. That's your length of BE. Then proceed with my calculation on arc length. 2 pi over 9 times 8, then I get 5.59. And I get the arc length of sector DCE as 2.09. So add all three up, then you get your results as 11.99 centimeters or 12 centimeters. Last part, which is the example 5 here, and the most troublesome or complicated ones as compared to the previous 4 questions. So we have radius of 10 as given by the question. The parallel information here is to confuse you. So they gave you the length of the minor arc as 14.8. This is crucial for you to identify the radian. And the area of the minor sector ODC is 21.8, and it's also crucial for you to identify DOC's radians value. So for you to find angles AOB in radian, so they gave you the arc length value, right? So we have theta times r equals to 14.8. So theta will be 14.8 divided by 10, you will get 1.48 radian as your final results. Moving on, in radian angle DOC. So for that, we are using the minor sector area, 21.8. So 1 over 2 times theta times r squared equals to 21.8. Theta will be 21.8 divided by 1 over 2 divided by 10 squared. Through that, you will get your calculation as 0.436 radian. So with these 2 radian, I then draw down this following shape here. Since they're asking for the perimeter of the shaded region, I can proceed by calculating AB first. So I label it as A. So theta times R, you will get 14.8, and C here will be 0.436 times 10, you will get 4.36. So most of the students will get stuck here. Then they don't know how to identify B and D's value. So to make that simpler, I actually drew down a line from the top to the bottom, which is the diameter. What I basically did was to cut the radian that they were identifying earlier into half. So pi, which is 180, minus half of the radian of AOB and half of the radian of DOC, then you will get 2.18 radian, and that is for the triangle over there. For us to calculate the BC's and AD's length, okay, I'm using cosine rule over here. So to simplify and make my working faster, I immediately multiply the result with 2. So 2 times the formula, sub in your cosine 2.18, and through this calculation you will get 35.5 centimeters. So add everything up, you will get 54.66 centimeters, which translates into 54.7 centimeters for this. Moving on, we have calculating the area of the shaded region. So things that involve here is half times theta times r squared. Okay, you will get 74 centimeters squared on this. And area of the sector angle DOC, this one you will get 21.8 centimeters squared through the calculation. So remember the radian that we identified earlier is 2.18, and substitute it into the half AB sin C's formula. So to make the workings faster, I immediately multiply it by 2, because BOC and AOD is the same thing. So after you multiply by 2, you will get 82 centimeters squared as your final results. Add everything up, then you will get your final answer as 177.8, and correcting it to 3 significant figures, you will get 178 centimeters as your final answer. So this is pretty much it for this particular topic. It is relatively easy compared to all the topics that I've covered. So I hope you are able to understand this, and if you have friends that are struggling, feel free to share this to them. So I wish you all the best in your upcoming examination. Thank you.